Powered parachute 7-2 takeoffs and departure climbs. In the context of a normal takeoff for a powered parachute, envision a scenario where you're aligning with the wind, and the wind conditions are favorable, ranging from light to moderate. An optimal takeoff surface would be firm, devoid of debris, and offer sufficient length to facilitate a swift acceleration to achieve the normal flight speed. Choosing to take off directly into the wind holds several advantages. A slower ground speed is essential as it minimizes wear and stress on the landing gear, ensuring prolonged durability and enhancing overall safety during landings. Secondly, the headwind aids in a prompt wing inflation, a crucial factor for a successful takeoff. Lastly, a shorter ground roll is necessitated, translating to a reduced requirement for runway length to initiate liftoff. Ensuring a stable takeoff, maintaining a minimum airspeed is crucial to sustain wing inflation and facilitate the required lift for a smooth ascent, enhancing overall safety and control. Abruptly cutting power post chute inflation may result in wing deflation, making recovery challenging. With escalating takeoff roll speed, the pressure on steering control tubes intensifies, emphasizing the importance of coordinating the cart and wing directions during this phase. Upon reaching the point where the wing generates enough lift to rotate the cart's nose off the ground, nosewheel steering loses effectiveness, necessitating avoidance of tight radius turns at this juncture. The lift-off stage occurs as the wing achieves sufficient power to elevate the powered parachute off the ground. Subsequently, during the initial climb, it's imperative to maintain the throttle setting that initiated the takeoff. Factors like prop torque and wind influence the direction, particularly due to the left-turning tendency associated with clockwise spinning propellers. A vigilant scanning approach is vital for maintaining direction, attitude, and collision avoidance in the airport vicinity. Considerations vary with weight, as lighter loads result in an earlier liftoff, steeper climb, and potentially more sensitive flight controls. Common errors during normal takeoffs encompass insufficient area clearance before staging, inappropriate staging position selection, oversight in setting up into the wind, abrupt throttle use causing stress on the wing, insufficient power for kiting, neglect of wing observation during inflation, overlooking the rolling lock pre-flight, abrupt throttle use causing porpoising, failure to anticipate left-turning tendency, and overcorrection for left-turning tendency. During the rolling pre-flight, steering controls play a role in reducing wing oscillation or aiding in centering. Adjusting control pressure helps counteract wing motion, ensuring a centered position above the cart. During the pre-takeoff roll, especially on soft fields, it's beneficial to press the pedals multiple times and hold them briefly after the wing comes overhead. This helps open outside cells by temporarily increasing internal wing pressure, aiding the transfer of pressure to the wingtips. Simultaneously, it ensures that the steering lines are free from impediments, avoiding entanglements with outrigger tubing or obstructions. Avoiding lockout is crucial, and improper canopy layout or throttle movements during the initial wing building can lead to a stall behind the cart. If lockout occurs, reducing power and simultaneously pushing both steering controls outward in a flaring motion can rectify the situation. This action pulls the wing back almost to the ground, and a rapid release of the flare allows the wing to slingshot up and overhead. Note that this method is not recommended for elliptical-shaped wings, as they may overfly the cart and land ahead of it due to reduced drag. Crosswind takeoffs in powered parachutes are limited, and it's advisable to take off directly into the wind. If the wind is shifting or blowing across the runway, it's prudent to wait for favorable conditions or cancel the flight if winds change rapidly. In the case of a single runway with crosswinds, positioning the powered parachute into the wind is essential. The initial inflation and kiting should follow the same procedure as a normal takeoff, adjusting the cart's direction after the wing is overhead. During the takeoff roll in a crosswind, steering bar control is used to turn the wing approximately into the wind, preventing it from pulling the cart to the downwind side. Adequate airspeed over the wing is crucial to generate lift and avoid the wing falling toward the downwind side, which could lead to a rollover. Even in the fast-paced sequence of a crosswind takeoff, conducting a rolling pre-flight, checking for lines free, cells open, and wing centered, remains important for safety. Let's break down the lift-off phase and crosswind takeoffs step by step. So, picture this. As the nosewheel starts to leave the runway during takeoff, control of the powered parachute shifts entirely to the wing's flight controls. Now, if there's a significant crosswind, taking off might take a bit longer because the steering control adds drag to the wing. But don't worry, the headwind and the deflected side of the wing act like a flared wing, compensating for this. As both main wheels lift off, there's a chance the powered parachute might drift sideways with the wind if you don't correct for it. So, to avoid an unplanned drift, maintain the right amount of crosswind correction by keeping pressure on the steering bar. Now, let's talk about the initial climb. If you're applying the right crosswind correction, the cart should rotate to align with the wing once you're airborne. But here's the thing, in a crosswind, you might need to use the steering bars assertively to keep the powered parachute on the intended takeoff path. It's like steering into the wind to counteract the drift. Keep climbing with this wind correction angle, following the runway centerline. However, because crosswind force can change quickly, keep checking your actual ground track and adjust your angle as needed. Now, let's address some common mistakes during crosswind takeoffs. It's crucial to clear the area before heading to the staging position and to choose the right spot. Make sure you have enough space for takeoff and for maneuvering the wing into the wind. And always observe the wing during inflation, don't skip that rolling pre-flight. In the event of a rejected takeoff or engine failure, you've got to act fast. If you reach the point on the runway where you should be airborne, but you're not, cut the power immediately. No excessive braking or trying to use your feet as brakes, that could lead to trouble. Instead, reduce power to idle, shut down the engine, and pull down the trailing edge to collapse the wing, turning it into a kind of drogue chute. And here's a heads up on engine failures during climb out. If it happens, the cart might rock back, potentially causing a dive. Your best move is to establish a normal glide for a routine engine out landing, unless you're really close to the ground, in which case, flare the parachute pronto to avoid a dive and soften the descent. Now, that's a wrap on liftoff, crosswind takeoffs, and handling engine failures during takeoff.